Good morning, good afternoon. Here we go again. Miss Lavnika and Miss Mate will be talking about factoring ax² plus bx plus c. What do you see different from the previous case, Miss Lavnika?
What I see different is that the first term has a coefficient a, and that a cannot be 1. That means it can be any other number. So I think that the questions will be a little bit more complicated than what we saw before.
Okay, so here is our first example, 2x squared.
Yes, but the concept is identical to what we've done before.
Well, that's good news for us. So, example 2x squared plus 5x plus 3. Quickly tell me A, B, and C.
A is 2, B is 5, C is 3.
Oh, that wasn't fast enough. Okay, so let's move on. What did we do with this 2x squared plus 5x plus 3? As we saw in class, we want to make a perfect rectangle. Were we able to make a perfect rectangle? Yes, we were able, as you can see it right here. Can you help me and tell me how much is my length right here?
Well, same thing as before. We have x length, and 1, 1, 1. So I have 2x plus 3.
You said an x, another
Plus
1.
1, plus 1, plus 1.
Okay, so that is
2x plus 3.
Okay, and over here,
the width will be x plus 1.
X plus 1. Yes, you're right. Now let's see if that's true. X, 1, 1, 1. X plus 1. Yes, that's correct. So there you go. Just by looking to our geometrical model, we can figure out that we can factor this polynomial as in 2x plus 3 times x plus 1, length times width, correct?
That's correct.
That's correct. Yes, but I want an algebraic model to factor. What is my algebraic model? We have to play again with sum and product, right? We need to look for two numbers.
That's correct. However, let's look at first and the last coefficient. And in this process, we have to multiply 2 and 3.
So I'm going to do 2 times 3, that is
6.
Okay.
So now what we are looking at, we are looking for two numbers, which if we can multiply, we'll get the answer 6. And if we add them together, we'll get answer 5.
Okay, the second one here, when I add them, I get 5, is exactly like last time. But how about with the first one, multiplication? Is it different from last time?
Well, it's not different. The last time we had a leading coefficient a equal 1, we just didn't really emphasize that we had to multiply first and last term. We just took a last term as it was given, and that's it. But at the end, we did multiply, even if we didn't.
Okay.
So, as we can see from a geometric model, it's 2 x's and 3 x's.
These two.
So I have my two numbers, and that is 2 times 3.
2 times 3
will give me 6, and 2 plus 3 will give me 5. So what we've accomplished now are the fact that the middle term 5x can be split into 2x plus 3.
Okay, so these, the middle term, let me guess, can be
split into 2x.
Okay, my 2x from exactly as I did before.
Plus 3x.
Plus 3x, the two terms that I got there.
And we are back into our old grouping, by factoring by grouping.
Oh, so nothing new from this point on?
Nothing new.
Okay. There you go. I practice a lot. I know how to do this. I make no mistakes. There you go. So common x plus 1 to x plus 3. I am done here.
That's correct. To check it, you use the expanding method.
We always
yes.
check, right? And we're gonna leave this with you. Do not forget, we always check. Good. Any other example for today? Yes,
So
we do.
here we go. We will stick with the method that we just saw in the first example. So when we multiply first and last coefficient, we'll get 30.
Okay.
And this is what we are looking for. Two numbers whose product is 30 and two same numbers whose addition or sum is negative 13.
Quickly.
So, if we are looking for those, I think it's negative 10 and negative 3.
Negative 10 and negative 3.
Negative 3.
I do
Let's
not
check.
believe. I always check. Negative 10 times negative 3 is indeed 30. Negative 10 plus negative 3. Indeed, you are right. Negative 3 is 30. Now I believe you. So I move on. I use my two numbers to break down my middle term into negative 10x, negative 3x
Plus 5.
plus 5.
And now again, factor by grouping.
There you go. And you know I'm very good at that, right?
Of course.
So what's common here? 2x is common. 3x minus 5. Oops. What's common here?
Negative 1.
A negative 1 I'm going to factor just because that gives me a 3x.
Common binomial.
There you
That's
go.
correct. So now we can finish the factoring with the common binomial. And here are the two factors for the original trinomial that was given.
You see how fast I am because I practice so much?
Yes, you did.
Good. So now we have more practice for you. As usual, when we have more practice, we want you to pause and do them on your own. So now it's time to hit the pause button. We are waiting for you to do that. And now, after you are done, here are the full solutions.